In this video, we'll be covering the polar coordinate system. The polar coordinate system is simply a different way to cut the general plane. So in most cases, you would create yourself an x and a y axis, and again, you'd have x equals 1 and 2 and 3 and so on and so forth, and you'd have y equals 1 and 2 and 3 and so forth. And this creates what we call a rectangular coordinate system. Notice how all these lines that we create intersect and they create these little squares. Well, they call it a rectangular system because, again, the way that these multiple different lines can arrange themselves. In the polar coordinate system, however, we cut that in terms of circles and lines. You'll notice that each circle is going to have a very specific radius. That's denoted as r. And each line is going to be denoted as having a very specific angle measure. That would be your theta. So in this case, what we're going to have is, if I have a point A at 2 comma pi over 6, that means that I'm going to go up pi over 6 units, and I'm going to go out 2 units. So I go 1, 2, there's my radius, but I'm going to go up to pi over 6. Now, to make this clear, there's pi over 3, there's pi over 4, there's pi over 6. And again, this is going to rotate perfectly around. This is my value 2 comma pi over 6. Again, we have to go out 2 units from the center of the circle, and we have to go an angle measure of pi over 6. On the next one, B, you have 1 comma pi over 2. Now you'll notice if we have a radius of 1, this is simply a value that's going to be on the unit circle. So for part B, I'm going to go pi over 2, which goes to here, and I'm only going to go up a value of 1. Now if I denote this in a very specific way, I could denote this as this being a value of 1. So this would be a value of 1, this would be a value of 1, and this would be a value of 1. So that point right there would be 1 comma pi over 2. If we look at C, which is 4 comma negative 2 pi over 3, we're going to go ahead and I'm going to draw this a little bit larger here. I'm going to go out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, what's important to notice about this particular graph is that these are not lines that are passing through. These are circular orientations. So I have a circle passing through those 4 points. I have a circle passing through these 4 points here. Okay, so that means that there's a circle passing through that fourth set of lines, and again, my radius is 4, so I have to go out 4 units. But I'm going to go out 4 units at negative 2 pi over 3. So very carefully, I'm going to calculate my angle measure. This is pi over 6, that's negative. This is pi over 4, that's negative. This is pi over 3, that's negative. This one here is a negative pi over 2. In here, we're going to go ahead and we'll see 1 pi over 6, 2 pi over 6, 3 pi over 6, there's 4 pi over 6, and here's 5 pi over 6. Now recall, if I have 4 pi over 6, 4 pi over 6 is actually 2 pi over 3. So I'm going to go negative 2 pi over 3, but I'm going to go out a distance, and I'm going to go ahead and draw this, of 4 units. So right about there. Again, keep in mind, this is not a straight line, this is a circular region encompassing that. Now again, this might not be drawn perfectly to scale, but that's that point right there at 4 comma negative 2 pi over 3. Lastly, for letter D, we have negative 3 comma pi over 6. So for negative 3, and we're going to pi over 6, I'm going to go ahead and do the same thing I did with the last graph, and I'm going to give myself 3 units all the way around. And I'm going to go to pi over 6. Now pi over 6 is going to be sitting about here, so 1, 2, 3. There's pi over 6. This location right here would be 3 comma pi over 6. But we're going to negative 3 pi over 6. So what's important to note is that for a negative angle, for a negative radius, we're simply going to go to that point, and instead of going there, we're going to rotate this thing 180 degrees around to the other side. So in other words, I'm going to go ahead and draw these lines, 1, 2, 3. We're going to be sitting this point, which would be here, to this point over here. Again, making sure that I'm very clear about putting that point right there at negative 3 comma pi over 6. So now you'll notice that negative 3 comma pi over 6 would actually be equivalent to a different value, say 3 of a radius, but this time we go 1, 2, 3, 4, 5, 6, 7 pi over 6. So those 2 points are actually equivalent in this coordinate system. They're equivalent because of the location of where they sit. If I were to do 3, 7 pi over 6, they're going to sit at the same location at negative 3, pi over 6. So make note that a negative radius simply reflects the point of where it would be 180 degrees around the origin.